This is the second video about subsets. This is our part 2. There are only 2 videos regarding subsets, so this section's a little bit shorter in the content area-wise. Here's my little sun set. It has some numbers in it, and it's the sun. Anyway, all right, so let's talk about proper subsets. The way we represent proper subsets is with this symbol. Okay, so instead of this, which is a subset here, a proper subset is just the top symbol. Okay, so this one up here is subset, and this one below is proper subset. And a set is a proper subset if all the elements in the first set are in the second set and the sets are not equal. So for example, if all the elements of A are in B, but they are not equal, meaning they have the same elements exactly, then it is a proper subset. So if A is equal to, let's say, 5, 6, 7, and B is equal to 4, 5, 6, the set containing 4, 5, 6, 7, and 8, A is a proper subset of B because the elements of A are in B, but they are not equal because A is missing 4 and 8. Okay, so that's what a proper subset is. It's essentially, it must be at least one element smaller than the other set. So that's one way to think about it, is looking at its size. If they have the same cardinal number, they cannot be proper subsets. Okay, so let's consider set A contains the elements 1, 2, and 3. Set B contains 1, 2, 3, and 4. Set C contains 2, 3, 1. And set D contains 2, 3, and 4. Okay, so we're going to look at sets B, C, and D, and we're going to see, is A subset of B? So the first one we're asking the question, is A subset of B? Are all the elements of A contained in B? Well, the elements of A are 1, 2, and 3, and B contains 1, 2, and 3. So yes, A is a subset of B. To answer the second question is asking, is A proper subset of B? Which means, are all the elements of A contained in B without the two sets being equal? Well, A contains 1, 2, and 3. B contains 1, 2, and 3, and 4. So they are not equal. So therefore, A is a proper subset of B. The second one here is asking, is A subset of C? Are all the elements of A contained in the set C? Well, A contains the elements 1, 2, and 3, and C is the set containing the elements 2, 3, and 1. So yes, C contains all the same elements as A. So all the elements of A are contained in C. So yes, A is a subset of C. Now when we ask the question, is A proper subset of C? That means that all the elements of A are in C without the two sets being equal. Because they both contain the exact same elements, the set A is not a proper subset of C. And then lastly, we're going to look at set D, and we're going to say, is A subset of D? So are all the elements of A contained in D? Well, A contains 1, 2, and 3, and D is the set containing the elements 2, 3, and 4. And so D does not have 1. So all the elements of A are not contained in D. So therefore, A is not a subset of D, and therefore A is not a proper subset of D because they're not even subsets. If you're not a subset, you can't be a proper subset. Okay, so that's kind of an assumed part of that definition. Looking here, we can say that there are kind of 3 different types of cases. You can have a subset that is also a proper subset. You can have a subset that is not a proper subset. And the last case is if something is not a subset of another set, then it cannot be a proper subset. So when is a subset not a proper subset? That is when the sets are equal. So looking back, we can see that sets A and C are actually equal sets. They contain the same elements. So therefore, A is a subset of C, but it is not a proper subset. So if the 2 sets are equal, then it cannot be a proper subset. And then for a non-empty set H, can we say H is a proper subset of H? Well, that is not possible. No, we cannot say A cannot be a proper subset, or H cannot be a proper subset of itself because they are equal. Okay, so let's look at the empty set. This gives us some interesting information that we can look at and consider. So we've looked at the empty set before, and we're being asked the question, is the empty set a subset of any non-empty subset? So if I were to write that out in symbols, is the empty set a subset of set H? And H could be anything that's non-empty. Okay. So let's think about this. If all the elements of A are in B, then A is a subset of B. And I drew a little Venn diagram that matches your notes to show this. So in this first case, here we have an example of A being a subset of B because A contains the elements 1 and 2, and B contains the elements 1, 2, 3, 4, 5. Okay, and then I have the non-example of a subset on the right-hand side because A is not a subset of B because 5 is in A, but it is not in B. So we first want to consider that. So we really want to understand what does it mean for something to be a subset. And so here we have that A, on this side, we have that A is not a subset of B because A contains an element that is not in B. Therefore, we can think about subsets in another way. We can say that if A contains no elements that are not in B, then A is a subset of B. It's saying the same thing. We get this double negative, right? In English, a double negative makes a positive. So the definition of a subset says that if all the elements of A are in B, then it's a subset. And then if I say, if A contains no elements that are not in B, then A is a subset of B. So it's the same idea, but this allows us to really understand what's happening with the empty set. By this logic, is there any element of the empty set that is not in B? Well, the empty set contains no elements. So there's not an element in the empty set that is not in B. So therefore, we can say that the empty set is a subset of any non-empty set. Therefore, this statement is true. The empty set is a subset of any non-empty set. So the last part of this section is doing an investigation to see if we can figure out a general way to figure out how many subsets a given set has based on its cardinal number. So what we're going to do is we're going to look at a list of sets. We're going to figure out its cardinal number, how many numbers or elements are in that set, and then we're going to list out the specific subsets and figure out how many there are. So the first set we're going to look at is the empty set. I drew that a little funky. So let's redraw those empty brackets. Okay, so here we go. The cardinal number of the set is 0. And we're going to come back and think about specific subsets of the empty set in a minute. We'll come back to this one. Now we have the set containing A. So the cardinal number of this set, which is how many elements does it have, is 1. And if we think about this, how many subsets does it have? Well, we have the empty set because it's a subset of any non-empty set. And then we have the set containing A. So this right here, the set containing A, has 2 subsets. Now let's look at the set containing the elements A and B. So the cardinal number of that set is 2. And if we were to list out all the subsets, we would have the empty set. We would have the set containing A. We'd have the set containing B. We'd have the set containing AB. Notice we're looking at subsets and not proper subsets. So when we have 2 elements in our original set, we end up with 4 subsets. Next, we're going to look at the set containing the elements A, B, and C. So the cardinal number of the set is 3. And if I were to list out all of its subsets, we end up with the empty set, the set containing A, the set containing B. My curly brackets are getting a little wonky. The set containing C, the set containing AB, the set containing AC, the set containing BC, and the set containing A, B, and C. Let me add the curly brackets. So you'll notice that when we have a set that has 3 elements, there ends up being 8, 1, 2, 3, 4, 5, 6, 7, 8 subsets. We could follow this pattern and look at this last example, but I'm going to fill in the information. And you can see listing them all out, I had to give myself some extra space because we have the empty set, the set containing A, the set containing B, the set containing C, the set containing D, the set containing AB, the set containing AC, the set containing AD, the set containing BC, the set containing BD, the set containing CD, the set containing ABC, the set containing ABD, the set containing ACD, the set containing BCD, and the set containing A, B, C, and D. And those are all the subsets when I have 4 elements, and I end up having 16. So we can see a pattern. Let's look back. 2, 4, 8, 16. Well, 16 is 2 to the 4th. 8 is 2 to the 3rd. 4 is 2 to the 2nd. 2 is 2 to the 1st. So looking back here, when I come here, I have 2 to the 0th power. 2 to the 0th power would be, is 1. Any number put to the power of 0 is equal to 1. It follows a pattern. If you look at this, we're dividing. If I start at 16, divide by 2. 16 divided by 2 gives me 8. 8 divided by 2 gives me 4. 4 divided by 2 gives me 2. And 2 divided by 2 gives me 1. So any number to the 0th power is going to end up being 1. So in general, based on this pattern, we could say that the number of subsets of a set is equal to 2 to the nth power. Based on that, to adjust the formula and address proper subsets, we actually can look back and say, okay, well, let's look at this example with this big one here. All of these are subsets except for the last one that has the same elements as the original set. So, in order to figure out how many proper subsets a set has, we can take 2 to the nth power and subtract 1. So if I have a set, let's say the cardinal number of the set is 5. So let's say I have set A and the cardinal number is equal to 5. Then the number of subsets is going to be 2 to the 5th. The number of proper subsets is going to be 2 to the 5th minus 1. So if we look at this, we can figure out, or look at different sets, we can figure out how many subsets it has and how many proper subsets that set has. So if S is a set containing the elements X such that X is a day of the week, well, we have 7 days of the week, so the cardinal number of the set is 7. Okay, so then the number of subsets is going to be 2 to the 7th, and the number of proper subsets is going to be 2 to the 7th minus 1. In the calculator, we can calculate that, or you might know it from the pattern, but 2 to the 7th is equal to 128, and so 128 minus 1 is 127 proper subsets for that set, and there are 128 subsets of this set. So when our sets get bigger, they have a lot more options for possible subsets and proper subsets. The last example is if I have T such that it has the elements such that X is in the natural numbers, and X is between 2 and 6. Okay, so that set in roster form would be 2, 3, 4, 5, and 6. So the cardinal number for this set is 1, 2, 3, 4, 5. So the number of subsets is going to be 2 to the 5th, which is 32. And the number of proper subsets is going to be 2 to the 5th minus 1, which is 32 minus 1, or 31. All right, and that's what we need to know about subsets. So please work on your 2.2 homework and email me if you have any questions. Thank you.